And just because I happen to be here, remember I said I didn't like the name of that snapshot file. I'm going to make it snap OPT because that's what our read, that's in our read file, that's the name it looks for. So what we've done is we've told the model we want you to read a set of initial conditions that were produced by a previous model run. We want you to write out a set of new initial conditions, and away we go. So what do we need to do? We need to save that. And everybody's with me so far? Okay. We're ready? So let's click on our water quality model, and away we go.
Okay, I screwed something up.
Excuse me?
Oh. I have clearly screwed something up.
What's the problem?
Okay, so I want to open the con file. There we go. And I want to go to, well, let's start at the bottom. What was that?
You've got output 2 for the ICO.
Right.
And for the snap.
186.
Excuse me?
180, that's the line number. Nope. Where's the initialization?
That's up the third, it's 104, I thought. No, go ahead down more. It's like the third input file.
Third input file. Flux, map file.
There you go. Outputs, yeah, that's correct. What, are you getting an error message, or?
Nope, just won't run. And then, let me make sure that I'm doing this right. The time, that's right.
Right. And you
What's the third
specified
number?
binary on the initial, the ICI is binary. That's
Where is
line
that?
104.
Let's make sure.
Binary, there you go. Okay.
Well,
And you save that.
wait, where is it? Where do you see? Oh, here it is, 108.
Binary, yeah.
Do I have extra lines in here? Somehow I put extra lines in here.
Let's see something. Okay. Binary on my, this is my control file.
Possible I got extra lines in here. I don't see it.
No, it's okay, don't panic yet. No, binary is line, on my editor, it's line 109.
That's what I got.
So I don't know what's, so let's double click on it. You know, let's try to run it.
Right. Okay, and that one.
No, you want the wqm.exe. This one right here, GNU.exe.
Right, that's what I tried to run.
Yeah, okay. Well,
Now,
One
we
of the
did run
prob-
first time.
one of the problems with running this in Windows is you don't get error messages. Well, you don't get error messages. If we ran this in Linux on the PC, you'd get an error message.
Gotcha.
For this moment, I'm just going to say you're hung up, and I don't know if I can figure it out right now.
There's a way to do that.
The
There's a way to
only
do
place
that.
change was binary, then just reading the initial file, then output to different file names, right? It's only change.
Okay, so that, so you got a Linux window?
No,
No.
got a Windows shell.
Okay, let's try that and see what happens. The other people who are running this, did yours execute, or did you have problems also? No problem, okay.
All right, but let's see. So I want to go to,
So you have to change the name for the output, initial file in the output folder. Right?
You do not have to.
Even though if you're reading it and writing it.
Yeah, you can do that, but it will write over it.
Okay.
And so if you ever want to repeat the run, you no longer have your initial conditions because you've written over them.
Right.
So that's why we
But it
changed
does
them.
not conflict with each other. It's just
No, it will not.
reading, then
It will not.
whatever you write it.
Yeah.
and then I want to run this.
I think you may have to click on the icon, not the name. Okay, what does it say? At line 1920 file main, the output, WCOM trade.
Maybe it's not finding that.
I see it.
Add value during floating point read. Something it doesn't like about the way you specified, I suspect it doesn't like some specification about that output file.
Okay.
Let's look at the control file.
Okay, so I specified the name. Well, I bet I didn't do that right. So it's the output. I know what I didn't. It's probably the input ICO initial conditions file.
No,
It's not, yeah, that's it,
yeah,
right?
yeah.
So let's do this.
Okay.
You know, Carl, we might come across a few of these problems going
Nope.
forward. And we might, if we come across these problems going forward, we might set aside maybe a 5-minute rule if we can't figure out the problem in 5 minutes.
Yeah, okay.
Right.
Because we've got a lot of talented people around the group. So
Thank you.
when we get on break, we'll be able to satisfy.
In the name of moving it along,
Yep.
we'll do that. So for those of us who are still following, we now have a new set output and a new water quality output file. Well, no, wait a minute. We need to run our, this one. We need to run our read snap file, okay? What we do have, I think, is a new output, WQM snap output. Okay, and if we look at the creation date, okay, so we need to read it, this one. The read snap file, the executable. Let's click on it, and we get that. What variable and phosphate, well, okay, phosphate in the water column, we decided was number 20.
Yep.
Phosphate in the water column is 20. And phosphate in the sediment, I think I said was number 12. And away we go. So now we're going to get into our Excel. We'll open up the water column. And next, finish. And what did we look at? We looked at box 25, so let's plot box 25. So actually, if you look at this now, phosphate in the water column is still diminishing. I wish I had saved the other file. What you really can't tell is that you need to look at that vertical scale. And if you remember your initial run, that was up to about 1. So what's happening is this thing is tapering off exponentially, and it's getting smaller and smaller and smaller, and we could probably go with this another 10 years if we wanted to. Okay, but you know what we're seeing is these things that are, this is phosphorus in the water column. You know, the things that are influenced by the sediments can take a long time to settle out. And if we, let's open up the sediment file, read sed file, that output. And we'll plot box 5. And you see that, in fact, the phosphate in the sediment is still diminishing, even after 20 years. Again, you need to look at the vertical scale. Okay, so it's not, you know, if you look at the actual magnitude, it's not decreasing tremendously in magnitude, particularly from our initial condition, it is still decreasing. So it's sort of a judgment call as to when you say, okay, we've spun the sediments up enough, close enough to equilibrium, we're going to call it a day. Typically, again, for the Bay model, we do a 10-year spin-up. And again, as I said, you start from an initial condition that isn't too far from where you want to, you know, hopefully you've already equilibrated those sediments, for example, to existing condition. So again, we started from the crudest set of initial conditions. But principle here, you know, we've done something in principle. We've started the model, we've run it, we've established that the water column, the residence time is about 2 years. We've established that the sediments, if you're interested in the sediments, you need to go 1 or 2 decades to really equilibrate. And we've learned how to loop, what I call loop the model. You know, we took one model run, we took the initial conditions from that model run and used them for a subsequent model run. So those are all take-home lessons, if you will, from this exercise. We could do it again. We could do it with different variables enough, you know what I mean?
I guess one comment, we're talking about the reaction rate for the G2, and that came to equilibrium within that roughly 7-year period. The problem with phosphorus, other than the generation of it from the organic, is the initial condition you're setting in the sediment. Phosphorus is basically conservative. The only loss mechanism is flux to the water column or burial. I'm assuming you're using 1/4 centimeter per year?
Yeah, I'm not certain, but it's,
Right.
yeah.
But if it's 1/4 centimeter per year, since the only way that this disappears is via burial, 1E folding for 0.25 centimeters in 10 years is 40 years. So that's why it's taking phosphorus, inorganic phosphorus in the sediment to come to an equilibrium, because the only way you lose it is via burial, where if you looked at particulate organic phosphorus, G2, that would be to equilibrium within 7 years. So again, just so you understand why, because we said, in 7 years you're there. Well, this is something, as Carl said, we're so far away from initial conditions, the only way to this comes to an equilibrium is through burial. Okay?
So box 9 and 10, actually, they are increasing all the time.
It could be.
Yeah, so check from 1 to 10. Looks like from 1 to 8, it's decreasing, but 9 to 10, it's actually increasing.
It might have to do with the boundary condition. You know, I haven't looked at every box, but it could well be that it's
9 to 10
increasing
are closer
slightly.
to the ocean.
Well, if you actually look at 10, it's lower than 9.
Yeah, but I mean, the trend is.
Oh, the trend, okay.
The trend is increasing. not-
Yeah. You know, there's all kinds of secondary effects going on here, and you know, I don't want to look at everyone and try to figure it out. I just kind of establish some broad principles about how to spin up, how to loop, you know, that sort of thing. Dan, please.
I think I have a different objective here. I want to know, starting from where I am now, what's going to happen in the next 20 years. which implies to me that what I want to do is to spin up, say, on 2013 conditions for 10 or 20 years, and then use that ICO file for all of my runs from now on. Is that correct?
You can do that, yeah. If you actually wanted to predict exactly,
Not exactly. I want to get a representative
Yeah.
sample.
you would do your best to equilibrate the model to the existing conditions and start from there. And you'd save that initial conditions file for
And
repetitive
that would be
use.
the initial conditions file for all my runs.
Right.
Now, just to clarify if I can, just to make sure I understand what Dan's saying, just in case there was another flaw. You were saying you would just run 2013?
For 20 years.
Well, the problem is there is year-to-year variability. So, for example, think about, well, let me finish if I
I
may.
understand.
Okay, so, but if you had a large change in flow from 2012 to 2013, you might really run those 2 years. That's what I'm trying to say. Because you're picking one condition, and is that year typical of the last 5 years? If it's not, then you really, because the thing is dynamic. Okay, so I just wanted to mention that as a
No,
clarifying point.
actually, that's a really good point, because
Okay.
what I was thinking about doing to get initial conditions, what I'm trying to do, is to run the 1990 through 2000 hydrology back to back and start from 2000. And that gets me a representative initial condition with all of the variance in it.
Okay,
Okay? That makes sense?
yep,
Good. Okay.
right.
And
So
that's
I just wanted to caution.
No, I
That's all.
appreciate that, and that's a really good point.
Okay.
That's what I would think about doing in order to get uniform initial condition set for a whole bunch of different management
Yes,
options.
right.
Okay.
Okay. So, okay, so I'm going to, unless there are further questions, I'm going to consider this exercise completed, and we're going to do one more exercise. Okay? Let's close this. So, I'm going to go back, and what I'm going to do is, remember I said that I didn't want to trash my original 30 box or WQM, whatever. So, I'm going to copy this thing again. And now I'm going to call this one exercise 2. And by the way, you on the website there were, I guess I did 3 exercises. So, you know, you can, if you didn't record this, or, you know, you can also see what I did by going up to the website and getting those exercises. So, now, all right, let's do something interesting. What we're going to do with exercise 2, we're going to implement a 40% reduction in nitrogen loading. Now, okay, so when I said let's do something interesting, if you will, let's not start this one with that funky set of uniform initial conditions. So let's go back to our